Lightning fatalities and injuries. According to the U.S. National Weather Service, NWS, lightning fatalities have averaged 32 per year over the past decade. Shows the latest decade of available fatality data, with the top panel showing the number of fatalities by state while the lower panel indicates the fatality rate per million people. The fatality rate turns out to be rather different from the actual number of fatalities, and indicates how the number of lightning flashes and the number of fatalities are related, but not as directly as may be expected. States with the highest fatality rates in the western United States appear to indicate a region with drier air and lower rainfall rates that give the perception that lightning is not as much of a threat as when it is raining heavily in other locations in the United States. Ranks of lightning fatalities per state, A, and fatality rate per million people, B, from 2005 through 2014 based on the United States National Weather Service website. The necessary ingredients of lightning frequency and population density in the United States have been combined in a recent study that is able to replicate the primary locations of observed lightning fatalities. This approach shows the concentration of fatalities in urban areas that have moderate to high lightning frequencies. Such a study has not yet been attempted in other countries where the lightning risk is very different due to such factors as the availability of lightning-safe buildings and vehicles, agricultural participation, and related societal differences. Underreporting of lightning casualties has been a problem in past years in the United States, but much less in the past couple of decades. A primary reason for underreporting is that about 90% of all lightning fatalities and injuries are to one person at a time, which leads to the tendency for such events to be reported less often in the media than multiple casualty events. With the inception of the Lightning Safety Awareness Team, a multidisciplinary group sponsored by the National Weather Service, it is probable that every fatality is documented, but an estimate is that only about 70% of the injuries reach the reporting system that is maintained by all NWS offices across the country. An additional issue is that underreporting may seem to be occurring when there is actually a definition issue. The National Weather Service in its storm data publication does not include secondary casualties due to lightning. For example, a house caught on fire at night due to lightning that results in a fatality or injury is not counted as a lightning impact, since the primary cause is coded as fire, not lightning. A useful method for estimating injury underreporting is the ratio of injuries to deaths. An intensive study over 3 full years across the state of Colorado showed that about 10 injuries occur per fatality. When the ratio is less than 10, an indication exists that not enough injuries have been reported and documented. The 10-to-1 injury-death ratio is assumed to apply to the United States and more developed countries with their similar socioeconomic infrastructures, providing widespread availability of lightning-safe buildings and vehicles. The lightning fatality rate per million people in the United States has dropped by more than 2 orders of magnitude since 1900. Similar trends have been observed in many more developed countries of the world with published lightning fatality rates during the same period. Also shown is the rural percentage of the population, which decreased from 60% in 1900 to fewer than 20% at present. The United States population not only transitioned out of a mainly labor-intensive agricultural society a century ago, but also moved into more substantial home and workplace buildings with grounded wiring and plumbing, together with the ready availability of fully enclosed metal-topped vehicles, better medical care, and greatly improved meteorological information about thunderstorms. All of these factors are present in more developed countries that have lower lightning death rates. Solid red line, United States lightning deaths per million people from 1900 to 2013. Dashed blue line, percent rural population. Graphs United States lightning fatality types 100 years apart, comparing the 1890s, top, with the 2005 to 2014 period, bottom. During the late 19th century, being indoors was the most common situation for lightning fatalities, while agriculture and outdoors were also a large component of the events. During the decade starting in 2005, indoor fatalities have become quite rare, agriculture events have greatly reduced from a century ago as farming became mechanized, and lightning-safe buildings and vehicles became common. Recreation and sports situations are relatively more frequent now than earlier. However, the overstated scenario of golf fatalities has been exceeded substantially in recent years by hiking, climbing, boating, and other water-related activities. Comparison of the percentage of types of the United States lightning fatalities in the 1890s versus 2005 through 2014. Worldwide, shows information on lightning fatality rates that has been collected in a number of countries during the last quarter century. Nevertheless, significant gaps exist in our knowledge of the absolute numbers. Studies have estimated the number of deaths per year attributed to lightning globally anywhere from a few thousand to 24,000, however, much uncertainty exists due to the limited sample size. One country of particular interest is Malawi, with a very high rate of 84 lightning deaths per million people per year that far exceeds the rate in any other country. The 1008 annual fatalities for this small but populous country may represent a very complete data collection method that is what adjacent countries in the region should report, so very large numbers of lightning fatalities may be actually occurring but we do not know them. If the 10-to-1 injury-death rule is appropriate for developing countries, then lightning is causing a large number of deaths and injuries worldwide, regardless of our inability to state the actual numbers. Lightning fatality rate per million people per year by continent. Red shading indicates rate greater than 5.0 fatalities per million per year, orange is 0.6 to 5.0, and yellow is 0.5 or less. White indicates no national summaries have been published for datasets ending in 1979 or later, updated with permission from HOLA. Many forms of labor-intensive work are far from lightning safety, such as a. Fishermen in open boats on Lake Victoria, the second largest lake in the world, and b. Fields in Nepal, courtesy Aquilnet and M.A. Cooper. In contrast with the United States, many populous less developed countries have as much as 90% of the population living and working in lightning unsafe locations and situations. During the day, many people are involved in labor-intensive agriculture, fishing in open boats, walking to market, or inside schools without recourse to safety in an appropriate building or vehicle, figures 8 and 9. At night, people live in lightning unsafe dwellings without adequate wiring, plumbing, or metal structural components that can carry lightning into the ground without affecting individuals inside. Most forms of transportation or going to market in developing countries are not lightning safe, such as a. Taxi in India, b. Ox cart in India, and c. Boda taxi in Nepal, copyright M.A. Cooper? An estimated 90% of sub-Saharan buildings and housing are not lightning safe, such as a. Farming settlement with thatch and sheet metal roofs on mud brick walls in Zambia, b. c. Combination shops and homes in India, copyright M.A. Cooper? In the developing world, the injury-death ratio is expected to be lower since fewer lightning-safe locations are available, resulting in a higher proportion of deaths. In addition, more people die per lightning event in the developing world than in the United States, particularly in agriculture and school events. For developing countries, counting both primary and secondary causes may be preferable until fatality rates decrease and the availability of safe locations increases. In more developed countries, the dominant profile of lightning casualties is the young male. Risk-taking in recreation, workplaces, and organized sports tends to be dominated by this group of males between about 15 and 30 years old. However, in lesser developed countries, the distribution is substantially more equal between female and male, and the ages are much more dispersed, both because of more widespread exposure. A recent study of labor-intensive agriculture in mainly India and Bangladesh shows that 47% of the fatalities and injuries were females as they work during the daytime when thunderstorms are most frequent. The lack of lightning-safe dwellings, schools, and workplaces means that all ages and both genders are equally vulnerable at all times. In developed countries, precautions against the effects of lightning to property, electronics, and utility lines are usually routine and subject to building codes using well-accepted practices for public buildings such as churches, hospitals, and schools. In developing countries, the effects of lightning damage to property can have not only direct effects on the structure but also indirect economic effects. The impacts include food spoilage from lack of refrigeration after electrical failure, electrical parts and repairs are unaffordable or not available for days, hospitals are without power, and databases and expensive, irreplaceable electronics are damaged.